Hey, it's time for lab. I provided a introductory video before that talks about what was done to do mitochondrial DNA comparisons, and now for the next 2 weeks in lab, we're going to be looking at our own mitochondrial DNA sequence comparisons that you've been assigned to do. So in the module, there is a handout that when you click on it, it's the Comparing Mitochondrial DNA Sequences. It tells you go to geneticorigins.org, which is what I've done here. And if you go to the mitochondrial control region, some more history, and at the bottom of that, it tells you to continue to the mitochondrial control region. And now we can get to where it tells us to go to the DNA sequence server. In your upper right, you see the DNA sequence server. We'll click on that. You will need to register and log in. You can use the service without doing that, but you cannot save your work. So you really need to get a username and password so that you can save your work. All right, this doesn't look like what I wanted it to be. There we go. So once you have registered, you'll get this page, and we're going to need to manage groups. That is how we will access the various sequences. And from there, we can save those sequences in our workspace, and we can select the sequences that we're instructed to compare. And so as you go through this handout, it tells you all the different comparisons. I will put up this document that is a summary of the comparisons you need to do. So we're going to use the managed groups to choose these sequences. So the first is Neanderthal versus student-teacher sets. So when you select managed groups, you'll get a pop-up box, and you'll see we have classes, workshops, etc. So what we want for our student-teacher sets will be classes. And I've looked through these, and you want to make sure there's at least, 10 or more people in them. The first couple are kind of sparse. I'm going to select that one. And when I bring it up, yes, there are multiple students in there, so that's a good one. And then I need Neanderthal DNA, and I'm going to need 5 pairs. So I could pick 5 different humans against the same Neanderthal. I could do 5 different Neanderthals against the same human. It's up to you, but you're going to do 5 different pairs. So now I need Neanderthal sequences. If I go back to manage groups, it doesn't, there, Neanderthal. And now we've got many different Neanderthals to choose from. I'm going to pick 1, 2, 3, 4, 5. So that's Croatia, Spain, Italy, Uzbekistan, and Belgium. That's a pretty good selection. So now I've got all my Neanderthals. And now I need to do 5 pairs. So one at a time, a student or teacher versus a Neanderthal. So I want to deselect this because I only want to do 2 sequences at a time. Scoot that up, make sure. Okay. So I need to do, let's see, where's my student? So let's do student 1, select that, and I'm going to pick the Belgian Neanderthal. And once I've selected the student teacher person and a Neanderthal, then I hit compare. You'll get another pop-up box, and it said that you want to make sure that the sequences are trimmed, and so we select trimmed and redraw it, and now we have the Neanderthal on top, the student on the bottom, and it has the sequences. Here it tells you we have 123 base pairs that are being compared, and that is from the whole possible sequence what was used, but we have 123 base pairs. And what you can do, you can print this alignment, which could give you a PDF, or what I have done is if you just highlight it, you can copy it, and then you can go to a Word document and paste it. So it looks exactly the same, and I can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 differences. So I'm just going to put that up here that we have. Oops. Close that. We have 14 out of 123 differences. And we could even calculate that to be, oops, just bring up a calculator. The calculator is taking its sweet time. There we go. If we do 14 divided by 123 times 100, that is an 11.38% difference. I'm going to save that. So I have it. So that's that one. You can close that sequence. You've saved it. Now I need to do this. Oops, let's cancel that. Need to do that for 4 more pairs. So that was 1 pair. So that was this student versus Neanderthal. I'm going to keep the same Neanderthal, and I'm going to pick a different student. So student number 5 versus that. Do a comparison. Make sure it's trimmed. And this person is, oh, way too many ends. We're going to not use that. You don't want to use a lot of ends. So student number 5 is not good. What about lucky student number 8? Lots of ends in that one as well. Wow, that's not polite. How about 23? Oh, that looks more promising. So we'll do the trimmed sequence, redraw it. And again, we have 123 base pairs. The Neanderthal on top, the student on the bottom. I will highlight that. Control C to copy. Go to my Word document, and I can have my second comparison. Paste it. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Out of 123 differences, which is, all right, 16 divided by 123 times 100, 13%. And you would keep doing that for each of your Neanderthal and student-teacher sets. And then it wants 5 different pairs of any 2 modern humans. So you've got this entire classroom, so you can pick multiple students. So we could do student 23 and student 24 and compare, and trim it and redraw it, and we could see how many differences there are in that sequence. So doing one-to-one comparisons aren't too different. Then you're going to do different pairs of a diverse modern human, which is the ethnic groups. So if you go to the manager groups, there are modern human mitochondrial DNA, and now you have all the different ethnic groups. So you can select several, you don't have to select all of them, but several ethnic groups. Then you'll have them in here, and you're going to look at different pairs of diverse modern humans. So Oh, let's see. I'm going to do, make sure I unchecked everything else. I don't want the students. I'm going to check an African American versus an African and see what turns up. Do a comparison. Always make sure you trim it and redraw. And now we have 276 base pairs. So that's why it's good to get a percentage, because the number of differences doesn't really give you a good comparison if it's not a percentage of the total number of bases that were looked at. So if I look at this one, highlight and copy that sequence, go back to my Word document, paste it in, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 300. Wow, that's pretty good. No, 10 out of 276. So, why do I keep closing my calculator? If we calculate that, 10 divided by 276. It's a 3.62% difference. Let's just move that over. And that makes sense, because before we're looking at random people and random Neanderthals versus modern humans, and now we're looking at an African American, which says that their ancestors descended from Africa versus someone who still lives in Africa, and their sequences are much closer. Back to my comparisons. And then we get a little more complicated. We're going to look at a modern human, which is a student teacher, versus 3 Neanderthals all at once. So let's unselect our modern humans. And there, let's see, 3 Neanderthals. So there's 1, there's 2, there's 3 Neanderthals, and there's 1 diverse modern human. And we're going to trim it. And now we have 111 base pairs. We've got our student tucked in amongst the Neanderthals, but again, the sequence differences are highlighted. But you're going to be looking for more than just the total differences. You want to look at where the Neanderthals are the same, but the modern human is different. The modern human is the same as 1 or 2, and where all 4 are different. And so you just look at where the highlighted regions are, and you can do all of your sequence comparisons. And then likewise, the same 3 Neanderthals to 2 of the diverse modern humans, the ethnic groups. So those are my same 3 Neanderthals, and I've got Belgium, Italy, and Uzbekistan. So I don't have, do I have an Italy? I've got Greece, Finland, Switzerland, Spain. Oh, I'll just pick that one, and why not an African? So now I've got an African, a European, and 3 Neanderthals, and I will compare them. Once again, trim it, redraw it, and I get 111 base pairs. And we're looking for these various comparisons, where the diverse modern humans are the same, but they're different from the Neanderthals. One modern human is different, but the other is the same as the Neanderthal, and likewise. And so that is how you're going to be doing your sequence comparisons.